to daily LeetCode day 97. Today is a momentous day, mostly because it is day 97. So we're back once again, right? Interesting times we live in. It's just interesting times we live in. I'm thinking about making an application, and yeah, it's just interesting times that we live in. That being besides the point, I think today we're going to do a weekly contest. So just getting into it, we promised Thomas we would do a weekly contest, and he did mention that this is and I'm blocking it right now, it is the ultimate chance to AC a contest LC hard. So likely this is going to result in us getting cooked, but my mind is open to see how we perform on this. So it'll be interesting to see. I'm pretty sure I'm washed up on mediums, and that being the case, we never really did. That being said, we never really did that many mediums. So it's likely we'll get fried. I think even the last contest we were unable to finish, but I have high hopes for this one, right? Because we've been doing great training. So I believe we can do this. We shall see, though. But much love to Thomas for this. That's what we're going to do today. So, yeah, we're back to an hour. Remains to be seen how long this will continue, but I think we'll try to stay for an hour for a bit. Unfortunately, I didn't get to record this as early as I like to, so I think one of the biggest things to figure out right now is the sleep schedule. So, yeah, we mentioned this stuff about Alarmy, waking up early, how to do that. I think Alarmy is just not going to work. So I always wake up beforehand, right? Because I know that the impending doom of I'm going to have to go out and scan a barcode in my car. I know the impending doom is coming, so it just doesn't work. If I wake up before then, I just preemptively turn off the alarm. So that's just not going to work. Maybe we can force it with something else, like a sunlight or a sunrise alarm or something like that. So I think that's what we're going to try next. Maybe I'll order one off Amazon. Nothing too crazy, but there's some really cool ones that might be able to solve the problem. Or I'll just get a Hue light bulb and just place the light bulb above me when I sleep, and then I'll set a timer on it so that it turns on at 8 a.m. Now this may be, I'm wondering, why would one do this? That's a good question. And yeah, I don't know the answer. The answer is I'm trying to wake up early, and for some reason that seems to be harder than doing anything else. So I want to extract more value out of the mornings, and I think it's a time that is just valuable. And I'm a night owl, so I'm not really certain how this will work in the long term. But I also don't think it's possible to sustain a schedule. I also think what I'm looking for is just silent, productive time, right, where things slow down, and also when conditions are correct. Usually when you wake up, you have more of your brain juice to spend. At the end of the day, though, it's just unlikely that there's anything left, whether it be through work, interpersonal relationships, or just the general stress or wear and tear of life. End of the day, the grind is just not that flames. So I'd like to extract some value out of the morning where I'm fresh or ripe, and yeah, that would be best. So maybe the sunlight alarm will work. I will let you guys know. And at the same time, if you use a sunlight alarm, if you have some tips and or tricks to waking up early, also let me know. So we're going to jump into it today, right? We're going to do 1 hour, see how far we get. And yeah, also don't forget to join the Hyperbolic Coding Chamber. This is a massive chamber that houses thousands and thousands of programmers. So you're going to want to join to stay up to date with the newest tips and tricks. There's also a command you can type, right, there's a command that you can type during any assessment that's going to spawn a GPT-3 instance on the spot, and it will solve the problem for you. It'll work for LeetCode, it'll work for personal projects. So you're going to want to have that code. You're going to make sure you're going to want to have that code out on hand. So that's pretty important. And yeah, so that is the plan for today. So I'm going to reset the timer, and we're going to jump into day 97 with the weekly contest. So I think the last one that just happened, was 312. I'm actually not certain how to find it. I should have figured this out beforehand. Oh, maybe it's just contest. Right, so this one starts in 5 days, which means the last one was 311, which means it's finished. So I think we can try it. Let's see, we have 4 problems. We shall see. It looks like there are some quick finish times. Last time I did this, there weren't that many. The finish times are around like 6 minutes or 5 minutes. So 7 minutes is interesting to see. So let's just jump into the virtual contest. Okay, so we're given this problem. I don't really know if it's an easy or what it is actually. User accepted, 13K tried, accepted. It looks like most people passed this if they tried it. Yeah, it looks like most people passed. It says difficulty easy. So given a positive integer n, return the smallest positive integer that is a multiple of both 2 and n. So we're given a positive integer, which is 5. The smallest multiple of both 5 and 2 is 10. N equals 6. The smallest multiple of both 6 and 2 is 6. Note that a number is a multiple of itself. The number goes up is between 1 and 150. So just so I'm understanding this, we want to return the smallest positive integer that is both a multiple of both 2 and n. I don't know if I'm thinking too simply about this, but since our range is, couldn't we just start from 1 and then go up linearly? We'll just say, we'll start at 1. And then just say, hey, is 1 mod 2 equals 0? And does 1 mod 5 equals 0? No. For 1, no for 2, no for 3, no for 4, no for 5, no for 6. The first one that is true would be 10. But we're given a positive integer n. Return the smallest positive integer that is both a multiple of both 2 and n. So maybe a solution could just be to count up to 150, right? If we find I don't even know if this is set up properly yet. My window is a little bit skewed. We'll do it like this. I'm not a big fan of this version of like, I'll just put it like this. So if let's just say if I mod 2 equals 0 and I mod 5 equals 0, right? Just return I. And then we should be able to find a number that falls within that value. I can't think for a case where this doesn't work. So let me just think for one more second. No, so let's just try it. Something feels off about this. Maybe I'm just thinking too much. We're going to start at 1, going up to and including 150.each do idx, right? And we're just going to uncomment these lines basically. And then we can just say return idx if idx, or we can just simplify it and just call it I. And we'll say starting from 1, going up to 150 for each index, right? We're going to have a variable named I. Return I if I mod 2 equals 0 and I, not mod 5, but mod n equals 0. The expected answer is 10 for 5. And if we use the example test cases, input. Wait, what? My input, oh yeah, my input 5, right, I get the answer 10. My input 6, I get the answer 6. So I think let's try it. Runtime error. So maybe I just run it again. I'm not sure why that runtime error. Last executed input was 77. So if I do a custom test case of 76. Oh, well, I guess what should we return when there's no? Well, yeah, there is one that counts. Oh, 77. Now there's no multiple that do that. So I guess what we should return is 1. Now if we use the case of 70, we should have thought about it a little more. If we use 77, well, it's unclear. What does it say? Give it about both a multiple of 2, both 2 and n. Wait, maybe I'm confused. Oh, n, right. The number that they're passing in goes up to 150. I see, but it doesn't mean that we stop at 150. This could have a pretty bad runtime. So I guess what I would do is just do 1 divided by 0. I think that should give us positive infinity. Equal Alright, this isn't very fast, so it's accepted, but this is pretty awful. We also didn't really think too much about what n meant. I wonder if you can make this faster. You're basically checking if it's a multiple. You could definitely, instead of counting up, since we're looking for a multiple, you could just start at n. And I think yeah, I think you could be a little bit faster if you just started at n. You could say while n is less than, or we could say, so while I is less than max, we'll say I plus equal n. Doesn't really show how much faster this one was, but maybe it doesn't matter. There doesn't seem to be that many people using Ruby anyway. But I think we're in the weeds. All right, let me see. And then we'll just go to, I think it would be linear time though with constant space. If we're starting at I could be 0 since we're looking for the smallest number. I mean, we're going to start at 1 for the smallest number, and n could be the integer, 64-bit integer max, to which we would literally just do 64-bit integer max operations, I think. So that probably wouldn't be pretty good, so, or maybe that's fine, I'm not sure. But we will go back to the contest. Here we have an alphabetical continuous string is a string. Alphabetical continuous string is a string consisting of consecutive letters in the alphabet. In other words, it is any substring of the string alphabet string. For example, ABC is an alphabetical continuous string, while a CB and ZA are not. So wrapping around and going out of order are not. Given a string S consisting of lowercase letters only, return the length of the longest alphabetical continuous substring. So here's an example. We have ABBA, KABA, and it seems like there are 4 distinct contiguous substrings, ABC. AB is the longest continuous substring. So we're looking for a contiguous substring, basically, that matches the alphabetical string above. And this whole string would be that here. So I think this is definitely a sliding window pattern. And I think the longest substring thing can be pretty much fixed by just checking the ordinance of the string. So I think we could, I can't delete spaces for some reason. I'm thinking sliding window, right? Output here, the goal output here would be 3, right? And I think the other question to ask is when to reset window. So I think as long as the current string, as long as we can start the window. Well, let's check our constraints really quick. So the string will at least be of string length 1. So we'll start our window with a letter to start, like the first letter A. Then we're going to have the remaining values to insert the remainder of the string to move through. So we'll say as long as the last character, right, which is A, dot ord, which would be 64, right, plus 1 is equal to B, then add it. Then we'll add it. Then as soon as that's not the case, we'll restart. So we do that for A, B, C. That all makes sense. And then when we get to G, it's no longer the case. So we add G, but then reset the window to start with G again. And then we check if G is 1 character away from M. It's not, so we reset with M, we reset with W, reset with A. So I think we could do that. Where we're going to say longest, right? The longest string is going to be equal to 1. Since the minimum value minimum input string of S, the minimum length that S can be seems to be 1. So we can just set longest equal to 1. And then now we want to do the sliding window. So I think we just want to iterate through the whole string basically. And what we can do is just say, we'll just say string will get S sub 0. And I just double check to see if we can do that. So you can. Right, and then we're going to say we just want to iterate, right, starting at 1, right, and going up to S dot length. Each we're going to have an index, right, and then we're going to do some work. The string is going to be given the first letter in the string to start. Then we're going to have 2 cases. I mean, we're going to need to know when to reset the window, and we're going to reset the window when the next letter, right, is not the next alphabetical letter. So to do that, also, what is this? This is an easy, I think. Oh, this is medium. Then what we'll say is S sub, string sub the last character in the string, right? Dot ord plus 1 dot char equals S sub IDX, or I mean it does not equal S sub IDX, right? Then then we have a problem, so we're going to start with A in the string, right? Then we're going to start the loop at B. We're going to say, okay, if string sub -1, which is A dot ord, which is 64 plus 1, which would give us an ordinance of 65, of 66, right? Because A is 65, I think. Right? This would give us a character of B, lowercase b, and we want to make sure that it's equal to, right, the character at index 1 in the string. Index 1 in the string is B. If they're not the same, right, then all you want to do is set string equal to empty, right? And then what we're just going to do is do string plus equal S sub IDX. And then all we should have to do is say longest equals longest I guess we have to keep, all right, longest and length of the current string dot max. So let's just see that this makes sense. All right, we start with string is going to be equal to a, right? We're going to say string sub -1, which would be the last character in the string, which is a dot or, which would give us 65 plus 1 is 66 dot char, which would give us lowercase b does not equal b. Well, it does equal b, so we're not going to reset the string. We're going to say string plus equal s sub idx, which gives us b, right? And then we're going to say longest, take the longest of 1 or string dot length, which is 2. So longest is going to be 2. Right, now we're going to say, okay, take the last character, which is b, add 1 to it, to its ordinance, plus 1, turn it back into a character. Is it the same as c? It is, so we're not going to reset the string. We're going to add c now, and now longest is going to be equal to 3. Now we're going to say, okay, take the last character of the string, which is c, and add 1 to it, which should be, we're looking for the character d. We have g though, so we're going to reset the string and make it empty, string plus s sub idx, which is g. Now we're going to take the longest of 3 or 1. The answer is 1. So I think this should work. So let's try it. So for this one, we do get the correct answer. Let's try the example test cases. We do get 2 and 5. It says accepted, but we don't really know how we did, so that's really strange. Usually they tell you, right? Don't they usually tell you how it performs? Since it's virtual, I'm pretty sure I could submit anything and it would say accepted. So that's kind of weird. So we'll just do submit. Oh, it did say it passed. Okay, so it did pass the test cases. It just didn't. The runtime seems to be abysmal. Or maybe this is all the test cases. I'm not certain. But we will take it. We seem to be in the bottom distribution. But I would say this would be linear time with respect to the length of the string. So maybe... Oh, did I close the contest? No, it was 311. I think is what we were doing. So let's try reverse odd levels of binary tree. Given the root of a perfect binary tree. What does perfect mean? I don't remember. Perfect means that it is perfect. A binary tree is perfect if all parent nodes have 2 children and all leaves are on the same level. Ah, man, that's what I... Actually, it's not. It's relatively similar to what I thought, but it's not the same. These are on the same level. The level of a node is the number of edges along the path between it and the root node. The tree has only one odd level, which is the first level. The nodes at level 1 are 3 and 5, which first become 5 and 3. Nodes at level 1 are 13 and 11, which are reversed and become 11, 13. For example, so it says given the root of a perfect binary tree, reverse the node values at each odd, level of the tree. For example, suppose the node values at level 3 are 2, 1. So you want to reverse the nodes at each odd level of the tree. So it's important to know that the root node starts at level 0. So that's important to know. We just want to swap the values, though, at the odd levels. If we had one more level here, how would this look like, though? If we had one more level. I wish they had shown us. Looks like the constraints, number of nodes in the trees, 1 to 2 to the 14th. Root is a perfect binary tree. I wish they'd give us one more test case, because I'm not certain if they mean given the root of a perfect binary tree, reverse the nodes at each odd level. Do they literally mean just reverse the nodes? So I think let's just go with that. Let's just go with reverse the nodes at odd levels. Let's just say reverse the nodes at odd levels. What I'm thinking is a BFS based approach. Keep track of nodes on a level. This approach. Keep track of nodes on level. Once level is processed, reverse node values. I think that would be the play. So I think we could do this, but if we scaffold this out real quick, if we did a BFS, we say, okay, we start at 1, we do 1, 2, right? We process the whole level. This is level 1. So we processed the level, right? We have access to both 3 and 5. Now we just want to use this processed level and pretty much iterate over these nodes and swap the values. So you have 3 gets the value of 5, 5 gets the value of 3. Okay, so I think we could do that. So to do that, I think we're going to do a queue-based version of the breadth first search, but we should usually do it with a deck since we're going to be unshifting off the front. So the worst case is going to give us n squared time when we unshift off the front on a regular array. So our queue is going to start with a root element, right, and the level that it's currently on, as well as a null element, right? So we're using I don't know what the word is, but I think in computer science, I think the Ruby, they call it like non-homogeneous array or something like that, where the array can have multiple types of items in it. But we're basically going to have an array of tuples basically, and when we reach null, it's going to denote the end of a level, right? And so we'll have something called cur level, which is going to be an array, right, of these nodes that we're going to keep on hand. So whenever we reach a null, we know that we're finished with the level. So with the queue, we typically do while the queue.length is not equal 0, right? Then you're going to want to take an element off of the queue. So to do that, we could say node and level, right? It's going to be queue.shift to take an element off, and then we're going to want to make sure that the node exists, right? So if node, right, does not, if node equals nil, right, then what we pushed off was the end of the level, right? End of level. Otherwise, right, we still have a level remaining. Otherwise, right, we're just working through the level, right? So if we look at this tree here, we pull off 7, we now have a null remaining, right? We reach the null, we realize, oh, this is the last element in this level, which is just 7. So if the node does exist, right, then we want to do is do cur level. We want to do is do cur level push node, right? So we want to keep track of that node, right? And then on to the queue, we basically want to push on the neighbors, right? So we'll say if, well, it's a perfect binary tree, so we know that the children exist. So we'll say queue dot push another tuple on, right? And what we're going to do is push those. We're going to recreate this value that we pushed onto with the root node. So we're going to push on node.left with a new level of level +1. Then we can copy this and do node.right with level +1 as well. And we also need to handle when the level is odd, which is fine, right? So we process 1 or whatever, we process 2, right? We push its children onto the queue. Let's just say we're using 7. We process 7, we push 13 and 11 on the queue. Then we pull the next one off, right? Node is nil, so it means it's the end of the level. Since it's the end of the level, right, you're going to want to do some specific work, right? Specifically, we want to clear cur level out. Yeah, we'd like to clear cur level out, I think is what we'd like to do there. And then the other thing is we'd like to say, hey, if level mod 2 does not equal 0, then we have an odd level. We want to reverse those values, right? Reverse the values at the nodes. Now to get those values, I think you can just do like you could do something like this. And we'll just say puts values. This is just Ruby syntax that's messing me up right now. Take a small one like 2, 3. Well, our example I think is unavoidable. So let's use example test cases and just use a simple one to start. And you can't, null doesn't exist in Ruby, so we actually want to swap this for nil. Level mod 2, undefined method mod for nil. Actually, now I'm realizing the other thing we want to do, right, is we can still keep the tuple structure going with nil, with the nodes that end it, right? So the other thing I forgot to mention, right, is that after we push these nodes onto the queue, right, we also want to do queue.push, right, null, right, with level +1 if, we can rewrite this to make it more readable, if queue.length does not equal 0. That way level will not be nil. I keep using null. I'm so used to null. Undefined method val. So what is it called? It is called val. And I think when you do collect, you have to pass in the pretty much the name of the variable. So our std out is 13 and 11, which is perfect because that is exactly the children that we have here. And I just basically want, with values, I just want an array, right, of the values but reversed. So we'll just say values.reverse. And you can, I'm pretty sure we can, like 11 and 13, right? And then all we have to do here now is just do cur level dot each do node, and we can just say node dot val equals values dot. So if we had 13 and 11 to start, right, and then we create a new array with the reverse value, so we now have 11 and 13. You can actually just actually, I think if we don't reverse it, I think you can just not reverse it and actually just do values dot pop. Save an operation. And I forgot to mention that at the end we need to return root. So the expected answer is not available, but our answer is 7, 11, 13, which is what they're looking for. I'm trying to think if there's anything that we missed. I think we're fine. Let's try the example test cases. Our answer is okay. 2538, 2538, 2538, 13, 21, 34, 13, 21, 34. Wait, I messed up. 2538. 2538, 13, 21, 34, 13, 21, 34. So that one works. 0, 2, 1, 1, and then 4 zeros. 0, 2, 1, and then 4 zeros. 4 ones, 4 twos, and then 4 ones. So we have 4 ones and then 4 twos. So this is a little off. We have our output is 4 ones and 4 twos. So 4 twos, while theirs is nodes at level 1 were 1 and 2, and our 2, 1 after reversal. The nodes at level 3 were 1, 1, 1, 1, 1, 2, 2, 2, 2, 2. So just to make sure that I'm understanding this, just print for each odd level that we reverse, we can just print it, and we want to zero in we'll just say, we'll do it like this. Should be easier to read. Oh my god. Wait.
If q dot length is not equal to 0.
Yeah, I'm breaking up the levels too soon. I think this block actually goes here. Because once we're processing a nil node, right, it means we reached a nil node. If we reached a nil node, it means we already pushed the children on, which means now it's time to add nil. We were doing it at the end of every level, which I think was creating conflict. In fact, it could even be the last thing we do. And I actually just said level plus 1. Oh, this is gonna get needs to go. So let's say we're doing that tree from earlier. We'll have 7, 13, and 11. 7 isn't nil, so we're going to go into else. We're going to push cur level.push node. So we're going to push 7. And then we're going to push its left and right child and add 1. We're now going to pull the next value off the front of the queue. And node is going to be nil, right? But does level mod level, which is 0 mod 2, actually gives you 0, so we're not going to do anything. We're going to say cur level equals empty array, and the queue isn't empty because it has 2 children in it. We're going to want to do q.push nil with level plus 1. So then we pull the next value off the queue, which is 13. I see. Yeah, it has no children. So I think we definitely want to do the thing where we say if dot not equal nil, I think this should stop that from happening. So we get 2, 5, 3, 8. 2, 5, 3, 8, 13, 21, 34. 13, 21, 34. Let's try the example test case with the one that was giving us trouble. We have 4 2s and then 4 1s. So I think this is correct now. So let's try it. I should have removed the puts, by the way. Time limit exceeded. I think the issue we're having trouble with here is the q, because q dot length can be up to n, and unshifting it from the front, or shifting from the front, creates an n squared operation, whereas we need like constant time. Not really certain what to do about that because we don't have access to a deck implementation in Ruby. Maybe we could do a small improvement and condense both of these linear time operations into one. So before we were creating an array, right? And then rewriting those current values with no.val, so that's 2n. Maybe we can just do starting from 0, going up to cur level dot length. We'll do level idx and then we'll say cur level sub level idx dot val should get the value of cur level sub cur level dot length -1 minus level idx dot val. So we have 0, right? If we had an array of levels like this, 11 and 13, we'd say okay, and level idx equals 0 to start, right? We'd say cur level sub level idx, which is 0, so 11, right? Dot val gets the value of cur level sub cur level dot length, so we have this array cur level dot length, which is 2 minus 1 minus level idx, which is 0 dot val, which is 12. I feel like that should work. Or it feels like that should work. For some reason, we're getting something completely different. So I'm going to try a smaller test case. Writing 7, 11, 11. Not understanding why that isn't working. Say cur level dot length -1 minus level idx. Alright, so at index 0 we'll place the value at 1, and then at index 1 we'll place the value at 0, but somehow we're ending up with, oh, I think I see what's going on. I see. What is going on? My keys aren't even like working anymore. I'm just pressing characters and my code is being destroyed. So I have no idea what's going on in the editor right now. Curl level.each do node. Yeah, I really feel like if we had a, let me see if I can find one. I feel like if we had a Ruby deck implementation here, we would be having an issue. Data too large to be displayed. We could do this. Maybe because we're having trouble, we'll just save instead of doing this values portion. We'll just do reverse, which will be an array. Whenever we do cur level dot push, we'll do cur. We'll do reverse dot unshift node dot val. So we're doing unshift. Yeah, is this no way? This can't. This is linear time. I think we're just doing a breadth first search. So that's just really strange to me. Why this would be. Yeah, I don't really understand. It would just we're just visiting the entire tree, so that would just be v we end up visiting every single node. I mean, there's a portion where we just... Yeah, this is strange. This one is a strange one. I don't really understand. Maybe there's a better way, I guess. Maybe you can do, like, maybe there's... Yeah, I don't quite understand. I don't quite understand this one. This one's too large to be displayed. Yeah, I don't quite understand why this is TLE. I feel like it's got to be the Q. I feel like the Q is giving... Alright, I'm going to do something drastic. I'm going to test this. I'm just going to literally copy and paste a deck implementation in. And then here, we're going to do deck.new. I don't think it has anything to start with. And then we're going to say deck dot push back so maybe this will work since now we're switching from it. While the deck isn't empty, we're going to do deck dot pop front say if deck isn't empty, then we're gonna do deck dot push back $89 and $90. Seems to have an extra. Undefined method modulus for nil class. 96. Wait, this person's doesn't even return the element. Which ones are we even using? We're using pop front. So maybe we'll just add that for pop front. So at start equals ends, only one node at start. Now we have temp equals at start equals at start dot next. Reverse dot unshift node dot val.
val
undefined method val for
this is 97. And I don't think we should have to do any other nonsense. My undefined method val for nil clause. Undefined method value for nil clause. Undefined method value for nil class. So deck.popFront.value is empty. Oh, I think I see what's happening. So I'm guessing it looks like the deck is empty now. Or maybe not. Oh, this doesn't make any sense. It just doesn't make any sense. I was hoping for an out-of-the-box deck implementation, and it was the worst one I've ever used. Undefined method value for nil class. How about we just say if value is not nil, then we just wrap everything in that. We still get reverse.unshift node.val. Oh, I forgot. We have to do value.value, which makes no sense. First dot shift, take a value off the front. This is clearly not the right answer, but I'm just curious if you end up getting time limit exceeded. Now, I don't even understand why this is now giving a value that is completely incorrect, even though all we did was looks like we might want to do something like say cur level sub 0. Yeah, I don't understand. I think the version that we wrote was linear time, but I think because of this deck stuff, it's just gotten out of hand, and I have no idea. So I think we're just gonna wrap up there.